My name is Jenico Daimin. Today I will present about the introduction of our assignment. First, synchronous sequential circuit is defined from the knowledge of its signal at discrete instant of time. It is much easier to design and then synchronized by a predict trend of clock pulse. It is shown in the figure here, and this is the timing diagram of clock pulse. Next, I will talk about the JK flip-flop. It behaves in the same fashion as an RS flip-flop, except for one of the entries in the function table. And the characteristic tables for JK flip-flop with active high J and K inputs, and JK flip-flop with active low JK inputs are respectively, and it is shown in the figure here. Next, the objective of this assignment is to understand sequential function, then that to understand the design of sequential circuit, and then to learn more about using JK flip-flop in sequential circuit, and the last one is to experience in designing the circuit in motherboard and be more expert in creating more complex circuit. Okay, that's all from me. Thank you.
Hello, my name is Muhammad Fakri and I will explain for the part discussion. Here is the truth table to show the current state and the next state of the input. When the input ABC00, the next 0, the next state also will be 000. We can understand more about the current state next state in state diagram we create. Here is state diagram that explained by Mr. Adam.
As you can see from the state diagram, when the H input gives two consecutive high, in other words 1, then G input will give logic 1.
Here the JK properties. When the input 0 and K 0, the output will be whole. 0 1 will be 0, 1 0 be 1, 1 1 will be toggle the output. And here is the truth table as we create from the truth table here. We get the for 0 0 when the current state 0 and the next state 0, the output of JK will 0 don't care, and we put the output in the table, so we can create the Carnot map by this truth table. Here is the Carnot map for the JK and KC. We circle all the table because we must circle the most possible, the biggest circle we can make. So the KC will be 1, same as here. The most possible we can circle is only 4 box, so the output will be just equal to A bar hash, same as the other table below. The output equation for the design is G equal to A bar B C bar hash plus A bar B C hash, and then when we minimize it, we will get the output G equal to B hash. Here is the part of our simulation in Proteus 8 Professional. As we can see, we use 3 JK flip-flop. We use the clock. We set the clock 0.5 Hz for to make it more slower, then we can analyze the output more clearly. Here for LED, these 3 LED to show the current state. As we can see here, 0 1 0, the state is 0 1 0 when LED for B is light on, and the output you can see yellow LED. When the state 0 0 0, the output will be 0. Then when it change to 0, 0, 1, the output still 0. Then when it change to 0, 1, 0, then the output will be 1. The LED will light on. And 0, 1, 1, the output still light on. 1, 0, 0, the output will turn off back. Here the flow, that is the flow in the simulation. Here the conclusion explained by Mr. Adam.
Now, as a conclusion, a flip-flop is a sequential digital electronic circuit. It is the basic memory unit in digital electronic. It needs a rising clock age or a falling clock age to trigger an output. An output that is based on the input which is applied during the clock activity. The logic conclusion would be, according to the input applied, there won't be any change in the output as long as the input remains unchanged and the clock doesn't transition. The change in the output would be possible only if the input changes and there is a clock transition.